Hello, ladies and gentlemen, and welcome to Mr. Saucedo's YouTube videos. Today we're going to be looking at two lessons, one of which is how you can convert between moles of different substances when we're doing stoichiometry, then how you can go from grams to moles and moles to grams when you're trying to do stoichiometry. So let's start with the simplest ones first, because this one is just kind of like the easy one, right? So one of the primary ways that we use stoichiometry is to compare how many moles of something you have to how many moles you're going to be making of another substance. And so what we call those are mole-to-mole calculations. And all you really have to do is you have to look at how many moles of A you have and how many moles of B you're going to be making, and you just use the mole ratio from your balanced equation. So that's kind of why this is the easiest one, because all you're doing is looking at the number of moles. You don't actually have to convert anything, really. You have to use a conversion factor box, but you don't actually have to do any unit conversions, which makes it a little bit easier. So for example, let's say it says you have this balanced equation. I want to know how many moles of water you could produce if you burned 25 moles of this stuff, C3H8. And it says it's in excess oxygen. You don't really need to worry about what that means, but all you need to know is that this is your given, 25 moles of C3H8. So what I always like to do is I always like to write what it gives me over the substance in the balanced equation. It always makes me keep track of what is going on. And then what I always like to do is I put an X or something over what it's asking me for. So how many moles of water? I don't know. That's my X. And notice the unit is moles. So how do I know this is a one-step conversion? Because I have moles and it's asking me for moles, I know it's one step. Okay? So what do I need? I need my conversion factor box and I need to know my mole ratio. So I want to know the mole ratio between water and C3H8. What is it? It is a 4-to-1 ratio, right? Now I can put in what I'm given, 25 moles of C3H8. I can put my ratio 4-to-1. And notice that I'm putting everything in my conversion factor box. Not just moles, but moles of, and then the substance that I wrote it over. Notice again, same thing here. I'm writing it so that I have 4 moles of water, 1 mole of C3H8. If you don't include the substances, when we do the harder conversions, you're going to get totally and completely lost. And until you can prove to me that you know what you're doing, you got to follow the directions, okay? So 25 times 4 divided by 1 is a 100. And think about it, right? If I know that for every one of these, I have 4 of these. If I have 25 of these, I'm going to have 100 of these, right? That just kind of makes sense. And that's how ratios work. Let's do another one. Pretend I have this balanced equation. How many moles of AlCl3 would I need to make 33 moles of KCl? So again, write down your substance that you're given above that and write your X above what it's asking for. This one's a little bit harder though, right? And that's because what is my mole ratio, right? Think about this. So what I want over what I'm given, it's a 2-to-6, or you can simplify that to a 1-to-3. It doesn't matter which one you use, you'll get the same answer. Okay, let's try it out. 33 moles of KCl right here. 2/6 or 1/3. It doesn't matter which one you do. I'm just going to do 2/6 though. So 2 moles of AlCl3 over 6 moles of KCl. Now why is this one a little bit harder? It's harder because this isn't a whole number. It's kind of a fraction. You can still probably have done this without needing this entire process, but it's always nice to be consistent, okay? Notice my moles of KCl disappear, and I do 33 times 2 divided by 6, which just so happens to be 11. And again, that kind of makes sense, right? If this is a 1/3 kind of conversion factor or a 3-to-1 conversion factor, if I have 33 of these, I'm going to have 11 of these. All right, now let's go to the harder one, okay? How can I convert between moles and masses, or masses and moles? So this is called a mole-to-mass conversion or a mass-to-mole conversion. And I actually need to know a little bit more information in this case. So there are two possibilities, and this is why people get a little bit confused by it. Either I'm given moles of A and it asks me to find grams of B, or it gives me grams of A and it asks me to find moles of B. So there are kind of two ways of looking at this, okay? I need to always use, though, the mole ratio, just like I did before, and I always need to convert to mass using the molar mass at some point. Let's take a look at the two examples and put them all together. Okay, these are two-step conversions, by the way. So pretend I have this balanced equation. How many grams of CO2 would be produced by burning 2 moles of C5H12? Okay, again, put what you're given and what you're looking for. Notice these are different units, moles and grams. That means this isn't going to be a one-step one, it's going to be a two-step one. So I need a two-step conversion factor box, but I still need to know my mole ratio. What's the mole ratio between these right here? The answer, it is a 5-to-1 ratio. So let's write down what we're given. I'm given 2 moles of C5H12. Great, I'm given something with moles. If I'm given something with moles, I need to use the mole ratio right away. So 5-to-1 goes right here. Notice, again, I'm being very consistent. Now, what is it asking for, though? It's not asking for moles, it's asking for grams. How do I go from moles of CO2 to grams of CO2? I use the molar mass. Now, think about where that would go. I would multiply by the molar mass because I want moles to cancel and I want grams in my answer. Now, notice everything cancels. I do 2 times 5 times 44. What does that end up being? 440 grams of CO2. Again, if you need to go back, make sure you go back and take a look at what I did. Let's try a different one. Pretend I have this balanced equation. How many moles of K2CO3 would I need to react to make 0.25 grams of KCl? All right, again, what am I given? What do I want? Notice that these are different, so it's going to be a two-step one, so I can draw my two-step conversion factor box. I need to know the mole ratio. What's the mole ratio between this and this? 3-to-6 or 1-to-2, doesn't matter. Next up, 0.25 grams of KCl, great. Notice this is grams. This is not moles, so I can't use the mole ratio yet. I need to convert this from grams to moles. So how do I convert from grams to moles? I use the molar mass. That just so happens to be 74.55. Notice grams is going to cancel. Now I can use my mole ratio of 3-to-6 or 1/2. Now notice grams is going to cancel, moles of KCl is going to cancel, and I'm left with moles of K2CO3 just like I wanted. So in your calculator, you can do 0.25 divided by 74.55, multiplied by 3 divided by 6. What do you get? 0.0017 moles of K2CO3. So you can see why the second kind of version of this is a little bit harder, okay? So make sure you go over these. If you have any questions, let me know.